We live on the cutting edge of physics, material science, engineering, and nanotechnology. Because at Lockheed Martin, we're engineering a better tomorrow.
Everybody, can you smell what the Rock is cooking?
Buddy, you're a
what is
boy,
that? I
make
think
a
that's
big
me.
noise playing in the street. Gonna
Some
be
smells,
a big
anyway.
man
All right.
someday. You got mud on your face.
And now let's meet Sarah Rowley, aka the Growly. Woo! Make some noise! Yeah!
Who let the dogs out? Who let the dogs out? Who let the dogs out?
All right. Ladies and gentlemen, boys and girls, welcome to Science Showdown. Boy, it's been an awesome day, hasn't it? I'm looking forward to kicking your butt. Everybody, here are the rules of Science Showdown. The rules. Topics are chosen at random. Each sci-athlete must present a demo based on the topic. Flags may be thrown for bad science, bad puns, bad hair, or excessive explanations. Or bad, anyway.
Or bad hair.
The audience will choose the winner after each round of applause, and we will award points. At the end, there will be a sci-athlete who will be chosen winner of this thing.
Right.
Really, I painted myself into a corner. All right, so without further ado, because I've had a lot of do today, shall we pick our first topic? First topic, please. I'll allow you, Growly.
All right.
Growly's choosing the first topic of the day.
Our first topic is air pressure. Got to demonstrate air pressure.
Air pressure!
Bring it.
All right, I can do that. All right, air pressure. Okay, air pressure. Everybody look up. Okay, okay, I get it. I see the ceiling too. Guess what? Above the ceiling right now, there's about 60 miles of air. You're at the bottom of an ocean of air, and that air is heavy. Air actually has weight, and we call that atmospheric pressure. Here's how much. Everybody make an okay sign like this. Now take that okay sign, put it on your head, put it on your knee, put it on the other knee. If you got a third knee, go for that. Back on your head, and now take a look at it. Now everybody, look at my okay sign. I am what you call a geek. I have measured my okay sign. All four sides happen to be 1 inch. Ladies and gentlemen, boys and girls, this is 1 square inch. Okay, anyways, on every square inch, on every part of your body right now, you have about 14.7 pounds of air pushing in here, here, here. Let me put it this way. Excuse me. Each one of you right now are holding up thousands and thousands of pounds of air. You don't notice it because we have air inside of our bodies pushing out. If we didn't, each one of us would be doing this right now. It'll be bad, Growly. So I'm going to demonstrate. Okay, you know what? I need 2 volunteers. I'm going to do some volunteers because I'm feeling crazy today. All right, let's see. I need how about my timer men? Timer men, come up. Timer men, here we go.
I'm up using the stairs, please.
I'm going to get to
Or
some signs.
the middle.
Here we go. All right. Well, thank you, gentlemen. Now, stand here. Now, take a look at these. What do these look like to you?
Phones.
Phone, yes, phone. You're right, you're right. Anybody had a phone this big? My first cell phone was this big, I swear. It was a giant brick. Didn't fit in my backpack. Anyway, a lot of people would say, Rock, these appear to be suction cups. How many people think we call these suction cups? Don't be afraid, raise your hand. Put your hands down because that's actually a bad description. They're much better described as pressure cups. Now, here's what I'm gonna do. I'm gonna take the pressure cups, I'm gonna put them together like so. I'm gonna put them together like so. So here's what's happening. Air pressure's pushing on you in all directions. It's pushing on you in all directions. But here's what I've done. The air that was in between these pressure cups, I have pushed it out. There's a lot of air pushing this way. There's a lot of air pushing this way, but there's very little air pushing out. All right, so do you think you're stronger than air?
Yeah.
Yes, I like the confidence. Yes, it's about to be crushed. Now, how about you? Do you think you're stronger than air?
Definitely.
Oh, awesome. Okay, grab that big handle, do not touch the little one. Grab that big handle, do not touch the little one. Listen, don't knock each other over, but do give it the good old USA SEF try. Go! They have no shot. There's 600 pounds of air pressure pushing in. I've done the math. They have no chance. Okay, stop. Okay. You know what? That was a really good effort. I think you did a really good job. Here, grab that. Not yet. Okay. Grab that little handle, squeeze it, both of you, and the air will come back in, the pressure will equalize, and they come immediately apart. A big round of applause for my volunteers. Air pressure! Thank you, guys. I was a little long in the tooth. Thank you for letting me get away with that.
All right, that was nice.
Air pressure.
That was nice. You guys rocked it out. Liked that. But I think we can demonstrate how strong the air is a lot more impressively. I have here with me today
Whatever.
a 5-gallon bottle.
believe
And
that?
I am going to use the air to crush this jug. So, to do that, first we need to decrease the air pressure inside of the jug. And to do that, I have with me some highly flammable, super top secret rocket fuel. There we go.
barely
We're
see
gonna
that.
put some of that fuel into this bottle, and we're gonna let that fuel mix with the air inside the bottle. And that air is going to heat up when I ignite that fuel, light it on fire. It's going to heat up, and it's going to go. It will be very exciting. We
hope
might
it-
all go jump a little bit. Very exciting. And when that's happening, that fuel and the air are moving out of the bottle. So we'll have less air in the bottle than outside the bottle. And then comes the really wild and dangerous, and do not even think about trying anything remotely like this. I am a highly trained, underpaid sciathlete. You guys are already underpaid, but you're not highly trained yet, so don't try this. I'm gonna stop the air from going back in. So, gloves are off,
Let's see some science.
goggles are on.
I'm getting ready to
Let's
flag
get
you.
that air out
Get
of the
ready.
bottle, crush the bottle.
Clock's ticking. Time! Hello? What do we... Thank you.
So the air is pushing in on the bottle, and there's just not as much air inside pushing back out. So the air outside the bottle has crushed it. Now, what's going to happen when I move my hand? Well, air always goes from high pressure to low pressure. And where do I have low air pressure? Inside the bottle. So where's the air going to go? Back inside the bottle, and our bottle's back to shape. Now that is how you demonstrate air pressure. All right, let's hear it. Yeah. All right, I think I won that round.
How many people vote for the growly?
And how many people vote for is it the rock or the beard?
I don't care. I'm interchangeable.
The beard? Okay. Who likes the beard? Yeah, I think I claimed that one.
What happened, guys? I gotta give that to the growly. All right, pick another topic. I'll pick. Here we go.
You pick.
I got two. Light.
Okay.
Light.
Light.
You want to go first with this one?
Gotcha.
I need a second. Okay.
So light is energy, and this energy travels in waves. Different lengths of waves give it different colors of light. So if we have a really long wave, that color would be red. If we had a really itty-bitty short wave, that would be violet. But here's the thing, there are some wavelengths of this energy that go beyond the rainbow, that are colors we can't even see. So I want to show you all some invisible light. And to do that, I think I need 2 volunteers. And I'm going to go with right there in the purple. Come on up these steps here. And let's have, this is always so tough right here. Come up these steps. And
pretty tough.
everybody
She's
wave
pretty
hi to
tough.
our awesome helpers.
That's pretty tough.
I'm gonna have our awesome helpers help me out with these flashlights. These flashlights shine out ultraviolet light. That is more than violet. Ultraviolet, more than violet, just off the rainbow. And we're gonna shine it on this board of beads. Now, is there a pattern there? Yeah, there's a pattern there. Let's take another look. We're gonna do a countdown from 10. So push that button on your light, point it at the ground. Point it at the ground. There we go. And then we're going to point it at the beads. We're going to go for 10, 9, 8. Help me out here. 7,
6, 5, 4. I'm bored.
2, 1, and That's different. So when we shine the ultraviolet light on the beads, that causes the beads to change color. Everybody give our helpers here a huge round of applause. Thank you. I'll take those back. You can get back to your seats.
I thought your helpers were great. Anybody find that a little boring? It's just me? Yeah, thank you, yeah. You know what? Let's
Invisible,
kick it up.
visible. That's so cool.
Let's talk about light. Now, normally light, it's in lots of wavelengths and it's sort of bouncing around. I brought with me today, well, basically the highest powered laser one can carry and still be legal. Ladies and gentlemen, boys and girls, I have a blue laser. You've heard of Blu-ray? Blu-ray is actually a violet laser. This laser...
Hold it.
Yeah, a blue laser.
A blue laser. You mean like the power of laser and wavelength of light that could boil your retinas?
Well, maybe. I mean, I don't know. I'm not going to boil my retinas today.
Yeah, don't shine lasers in your eyes. They will boil your retinas. Ends badly. Don't do it.
In fact, could I ask the two of you just to scooch that way just a little bit for me? Okay, and maybe just a part there. There we go. All right. So here's what I'm going to do. I happen to have here a red balloon. I'm going to take that blue laser. One of the reasons lasers are so powerful is that the light is concentrated, it's collimated, and it's coherent. That means that it's all one wavelength, and we see that one wavelength in this case as blue, about 450 nanometers. So I'm going to shine this powerful laser at this balloon, and we're going to see if that energy is reflected or if it is absorbed. That's a funny word, absorbed. Everybody say absorbed.
Absorbed.
I think it's a funny word. All right, here we go. Are we ready? Here we go. Safety protocol. Let me try again. So you can see the red light actually absorbed the blue laser, but it actually passed through the clear balloon. If I actually had a blue balloon in here, there's a very good chance that this laser would not be powerful enough because most of that blue light hitting the blue balloon would have been reflected. Ta-da! It's a laser! It's a laser! All right, how many people enjoyed The Rock's laser? I can't even break, oh, I thought I could break it. I couldn't break it, I'm sorry.
And who liked the invisible light? Yeah! I got the girls.
Invisible light!
I think the laser deserved one. We'll be nice. We'll give him one for the laser. Let's
Put the
do...
laser back here.
Sarah is a big, stinky Paul. What? Why would you do that? Hurts. It even has stick lines. All right, let's just try that again. All right.
Okay,
This time we are going to go with combustion.
Yes! Combustion! Do we have some, do you have a combustion demo?
I could get us started on combustion. So, of course, combustion is the chemistry of fire. And, well, in order to have fire, you need 3 ingredients. The first ingredient you're going to need is a fuel, something that can burn. And in this case, we are using a ground-up moss we call lycopodium, and it is very flammable. The second ingredient we are going to need to make a combustion reaction is heat. So, our heat source today is going to be a candle inside this jar. And then the third thing we need is oxygen, or an oxidizer. There are situations where you can get things burning underwater if you're using something other than oxygen as your oxidizer. Now, lycopodium is a very, very, very fine powder. There's not a lot of space between each grain, which means we need to spread them out so that there's enough space for enough oxygen to get between those grains to give us that nice combustion reaction. So I'm going to put some lycopodium in this jar, and it's going to, poof, combust. Are you ready? All right, let's do this.
I'm not feeling
In
this.
3, 2, 1. Really? Who made this jar?
I'm getting ready to throw the flag. I'm throwing the flag.
All right, well, sometimes things don't work on the first try, so what do? We go in 3, 2, 1. That is combustion.
That was good. That was cute. That was cute.
Smells like bacon.
Smells like bacon. Oh, I
Much
love
better than what The Rock was cooking
that. My
earlier.
next show's going My next show is going to be about bacon, everybody. Come and see it down in Philly. It's going to be a bacon show. You know what? Once again, I think that was good, but you know what? I can add even more air. I can aerate those tiny little particles of this spore called lycopodium. Lycopodium! Whoo! Combusted for the very first time. I'll throw a flag on myself. That was horrible. All right,
that
now
was
listen.
pretty awful. It's like, where are the
That was
flags?
awful. All right. I happen to have a very special apparatus. I'm going to take some of that very same lycopodium. I'm going to aerate it a lot more, and we should have ourselves, ladies and gentlemen, boys and girls, what we call the fireball of death. Except no one will die. Of
Listen,
course,
this
that
is
was-
not a death show.
That would be bad. All right, here we go.
Not a death match. Not into that.
This is going to be awesome. By the way, do not breathe lycopodium in. It's like breathing in toner. Trust me. It's bad. All right, here we go. Could you give me a countdown, please, Miss Sarah? Oh, wait, I need some more. Countdown from 5, 4.
3, 2, 1.
Lycopodium! All right, how many people vote for the growling?
Yeah! Hear it! And how many people vote for the beard?
Please, please. I need some of it now. I'm dying. I need a moment. I'm tearing up.
I think he gets right
That
there.
was good. That
It's
was
a
good.
tie.
All right. Okay.
One each. All right.
Good.
One each.
That was awesome. Fireball. Fireball.
Fireballs. Can't go wrong with combustion. You can't go very wrong with combustion. We do have a fire extinguisher up here.
All right. Let's choose the next thing. You ready?
All right.
I got it. I got it. Flight.
Flight.
Do we have a flight category?
Yeah, we have a flight category. I think
Okay,
this
flight.
is a good
Let's
one
do
this
it.
year.
Time
All
check.
right.
Time check.
All right.
Thank you. All right. We're good. All right.
Well, we're talking about flight. I'm gonna need 2 volunteers because we gotta get something flying.
Get some volunteers.
And I'm going to go with right there in the blue. Come on up and let's have somebody from this side. Let's have standing with the white shirt and the gray over. Come on up.
Hi. Welcome to the stage. How are you? My name is
Hello?
Paul the Beard. I'm Paul the Beard. Vote for me. Vote for me. Oh, come on up. Here
And
we
we're
go.
gonna have everybody wave hi to our helpers.
Hi, helpers.
Now today, what I am going to fly is a hot air balloon, and you guys are gonna help me out with that. So first thing we need is something to heat up the air inside of our balloon, and a chimney, so I'm gonna put this here. I'm gonna check what's above me. There we
I
go.
think there's plenty of hot air coming from the growly myself.
Beats the hot air that's coming from you. All right, let's have my friend here stand right there. Keep your feet planted, don't let them move. My friend here, come stand right here. And here I have a handmade hot air balloon. We are going to heat
nice
up
balloon.
the air inside this balloon. And as that air heats up, I'm gonna have you hold that right there. As this air heats up, it's going to get, reach and grab right there. It's going to get less dense. The itty bitty pieces of air that we call molecules are going to speed up, spread out, and we're going to see our balloon expand. And as it's doing that, it's getting less dense, and it'll eventually get so light, so low density compared to the air around it that it should float.
Should,
Hold it up. Whoa, hold it. Stand up.
should being the operative word. Yeah.
Stand up a little higher. We need our balloon to stay at the top right there. Don't let that move.
This is a big balloon. This is extra big. I see you kicked it up for the festival.
Yeah, I took the 5-panel one.
This is like a giant balloon, yeah.
Yeah.
Well, good luck getting that air hot. But that's hard to do with a big
Little
balloon, I
lower.
know.
There
Oh my
we
gosh,
go.
you're actually
so
doing it.
as the air heats up,
Wow.
our balloon is
Normally this doesn't
expanding.
work.
We haven't added any air in. All we've done is heat up the air inside the balloon.
Really?
And
This
that
doesn't
air is
normally
getting
work.
less dense. How's the balloon starting to feel, friends? How's that feel? You feel anything over here? What are you feeling?
It feels more.
It feels warm. That's because that air is heating up. It's got lots of energy. It's less dense. And I think we are going to, at the end of a countdown, let go. So let's try in 5, 4, 3, 2, 1. Let go.
Oh my, oh. Yeah, you're gonna do that one time. That's a one-off. Tomorrow's show, you're screwed.
Oh, it'll come back
It's
down.
not coming down.
See, is it
That's
still
gonna
near
stay
its
up
heat
there
source,
for
though?
the rest of the day.
No, it's not near its heat source anymore. So as time goes on,
Seriously, why
the
is it
heat
not
energy
falling?
is going to transfer to
Why
the
is it
air around the balloon. That air inside the balloon is going to cool off. It's going to get more dense, and if it isn't caught on a pipe, it will eventually come back
On
down.
the screen, maybe. On the screen.
Maybe.
There it goes, slowly but surely. It'll come
Everybody
back
on this
down
side,
later.
blow really hard this way. You're not blowing.
That
I can
actually
see-
worked.
Oh,
Let's see if we can get it back. Is it coming back down?
came down. I was so concerned about that. Yes, all right.
Yeah, the hair didn't work.
That was good. That was good.
Everybody, give our helpers here a big round of applause. You can head back to your seats.
You guys did awesome. Did you see it go up?
All right.
And then it came down? Can we do it again? We don't have time.
We don't have time to do that again.
All right, give 'em a
Head
big round of
on off
applause.
the
Excellent
steps
round.
back to your seats. Another round of applause. They were awesome.
I didn't know she was going to bring the hot air balloon, so I brought something small, but yet I think wonderful. We all know about the Wright brothers. They were the first ones to fly. There were a lot of people trying to fly, and I think one of the
They
reasons the
weren't
Wright
the
brothers...
first ones.
Huh?
I'm calling a flag on that one.
They
The
were one
Wright
of the-
brothers were not the first human beings
They
to
were-
leave the ground, stay up there a while, and come back safely.
They were one of the
The
first...
Montgolfiers.
Foul! Monk... I don't have a flag! Get back to your side.
The first human beings to fly, by the way, did that in a hot air balloon.
Well, in an airplane, we're being ticky-tack. In an airplane, the Wright brothers were first. We all know about the four forces of aerodynamics. We have gravity, that pulls everything down. We have a forward force, which is called thrust. We have the, what pushes us back from thrust? We have that thing called drag. Thank you very much. And then we have, of course, lift. I'm going to achieve lift by using my airplane today. I want you to notice, though, normally we need an airfoil shape. There would be a curve on the top and flatter on the bottom. This creates a difference in air pressure, which actually gives us that force called lift. But notice, these wings are flat. But I happen to have a really good propeller. Think of a propeller as like a spinning wing. When this spins, it's going to create faster and slower moving air, and we're going to create the force of lift right here in the convention center. Aren't we naughty? I don't know what that means. Anyway, okay, so listen. Gravity's trying to pull this down. If this goes up at all, even this much, against the pull of gravity, we have created lift right here. I'm ready to do this. Everyone over there, heads up. 3, 2, 1. Oh, my lights out.
Oh.
Thank you.
You don't get extra points for a crash landing.
You know what? I'm willing to take it. Let's move on. I'm taking a beating on it. That didn't. We got a little
Who
lift
likes
right
the
here,
hot
right?
air balloon? And who liked the crashing airplane?
I love science. I love science. I love turtles too.
I'll take it as long as I'm winning.
Okay,
All right.
let's move
keep
on.
going.
I died on that one. I
Yeah.
bad.
Yeah.
That's called my mulligan. Ask your moms and dads about that. That's a golf term.
Action and reaction.
Action and reaction. I'm gonna go.
Go.
Okay. You know, for those of you who saw Dr. Kabumi talked about action and reaction, I have two favorite scientists. I have a guy named Galileo, and then of course someone named Sir Isaac Newton. Law number 3, action and reaction. Everybody, I'm gonna fire for you today an air rocket. Here we go. Work with me, work with me. All right, now, right now, this balloon is really squeezing that air, and the air really wants to get out. Listen closely. It's a funny noise, right? Anyway, Here's action and reaction. If I have a push in one direction, Newton told me I'm going to have an equal push in the opposite direction. Everybody, if the air goes this way, which way does my balloon rocket go? Point! Action and reaction. If air goes this way, which way does my air rocket go? Action and reaction. So, air pushing down is going to give me an equal push up. Behold the glory. 3, 2, 1, yeah!
Okay.
It's not my day, folks, but
Rocket,
not my day.
balloon,
Just gonna sit here and watch.
or
Did you see that?
rocket.
It's up there. I didn't get it.
We gotta light a real rocket here. So,
It's stopped.
I know some people do get this one confused. Some people, when they see my rocket, they go, oh, no, that's not a rocket, Crowley, that's a soda bottle. Let me show you the difference. It's easy to get these mixed up. This is a soda bottle. This is a rocket. I'll show you that again, because it's easy to get them mixed up. This is a soda bottle. Rocket. We're keeping it in the rocket orientation. We're going to put some of my
Corny. That's
favorite
corny.
highly flammable
Corny.
rocket fuel in there. How do you think? One spray enough? Nah. How about 2? Is 2 enough? Trust me, 2's enough. And
Yeah,
then we are going to put on a highly engineered rocket nozzle, also known as the bottle cap with the hole in it. Now, as you know, when we light this rocket fuel on fire, that rocket fuel spreads out, and it's going to push down, out, through our highly engineered rocket nozzle, and that's going to give us an action. So we should have an equal and opposite reaction. Okay.
Are we gonna launch a rocket or what? Really?
It's worth the wait.
Didn't take NASA this long to get a rocket up. Jeez.
I didn't complain about your pressure cups.
That's because it was cool.
This is cool too.
You sure this is gonna work?
Oh yeah. All right, now, does my rocket have brains? No. Does it have fins? Does it have a guidance system? Keep your eyes open. I don't know where it's
We
going to
don't know
come
where
back
it's gonna
down.
go. Yeah, it's gonna go anywhere.
All right, let's light this candle and launch it already, which, by the way, that was a hilarious NASA joke. And we're going to go in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Really? There we go. Rocket!
That was really spectacular. How many people like the Growly's rockets?
And how many people liked the Ponytails balloon? They liked it. I think it's about even.
I have to say, I'm on a roll. Thank you, everybody. I was getting my butt kicked. All right, let's get another topic. You know what? Can I just choose a topic? Because
Just choose a topic.
Weather.
Weather?
I have a really good weather. Can we do
You
weather?
think
Want to
you
see
have a
someone
good weather?
Okay. Everybody, we like to. We have a weather show. I love it. It's one of my favorites. And so today, I would like to make for you something in weather that's called. Well, I can't make for you an actual tornado, but I can make for you today what I call the fire tornado. So here, I'm going to have a little fire in the bottom of this. I'm going to light it. And the one thing we know about tornadoes is that we know that there's air because of convection going up really fast. That air gets hot, it goes up. When it gets cold, it drops. So air's going up and it's dropping really, really quickly. We have a column of air. That column of air is spinning at different altitudes. When it starts to spin, we have something called the conservation of angular momentum. In the interior of the vortex, it's spinning much quicker than on the outside. Think of a figure skater. When they come in really close, they spin very quickly. When they open themselves up, they spin much slower. very similar to what's happening in a tornado. So I need that shearing wind. That is what the trash can is going to provide. It's going to provide that shearing wind, and we're going to have ourselves a fire vortex. They actually do exist in nature. They're called fire devils. You can see them in forest fires or in a house fire. So everybody, behold, where's my, my hot glove, just to be very safe. We're trying to be safe here today. Safety first, everybody. Here we go. All right. Notice we do not have that traditional vortex. We need that shearing wind. Everybody, the fire tornado. So that mesh trash can is acting like a shearing wind. That shearing wind actually gives us a vortex. You'll notice when that shearing wind stops, we've lost our vortex. One more time, the fire tornado. Yeah! Fire tornado. And the best way to put out your fire tornado, of course, is, well, liquid nitrogen. That's what you need. All right, there you go.
That was pretty cool.
By the way, don't try this at home.
Actually brought it.
Let me say this very importantly. Don't try this at home, everybody. Really, something you should do at your neighbor's house. You know, so you can clean up. Actually, don't do it at your neighbor's house. Don't do it. Rowley?
Highly trained, underpaid. Don't forget that highly
underpaid,
trained
yes.
part. All right,
Underpaid.
so I like the tornado, but I think I'm all about clouds. I think we
like
should
clouds.
make a cloud. So a cloud is formed when the water vapor that's mixed with our air. Think about those super humid, sticky days we get in the summer. When all that water vapor mixed in humid air rises up into the atmosphere, it gets cold and it condenses into itty-bitty tiny droplets of liquid water. And when it does that, it makes a cloud. Now, sometimes, for the most accurate in the crowd here, sometimes we get ice crystals or water or both. But either way, we're going to make a cloud. So to do that today, I'm going to use some liquid nitrogen. I use a lot of liquid nitrogen. This is going to cool off our water vapor. I think that's a good start. And then I'm going to have my friend sit back down on the floor. Thank you. I'm going to put on my safety equipment.
How am I doing, by the way? I'm doing pretty horribly here, aren't I? Oh,
Safety
my
equipment.
goodness. Oh, my goodness.
And then, Paul the Rock, Paul the Beard, could you come hand me the water? We are
Yes,
going
I
to drop
can.
some hot water
Cooperation. Cooperation amongst the masses.
into
Wow, that water's hot.
our liquid
Please be
nitrogen.
careful.
Got it?
Yeah.
In 3, 2, 1. I can't see. Okay, there you are. Got it.
That's a good cloud. That was good.
Cloud.
That was good. Not too wet. We're good. We're good. That was pretty good. That was pretty good. All right. That was pretty good. All right. How many people liked my fire tornado?
And who liked my cloud?
So loud. I think I'm deaf. I think I might have lost some hearing. I think I've lost some hearing here. I believe. Hello? What? Did you? Okay, let's
Yeah,
keep
that
on
works.
going here. Time check. Time check. Okay, hey, thank you for keeping it honest, fellas. Time check. What's the time check? Time check. Oh my.
What do you want to do next?
Let's keep moving. I'm going to
feeling-
double check the scores. That doesn't seem right. All right, what do we got?
States of matter.
States of matter. Why don't you want me to go first?
Yeah,
You wanna go-
I'll take it. So
States of
you
matter.
just saw some of the amazing things we can do with liquid nitrogen. Put out fires, make giant clouds. Well, liquid nitrogen is a liquid. It happens to be the same type of matter that's in our air. In fact, sometimes we call liquid nitrogen liquid air. And it boils at negative 320 degrees Fahrenheit. That means that's the temperature at which it changes from a liquid to a gas. And while that gas, it's going to heat up until it's the same temperature as the air in this room. And as we know, as we saw with our hot air balloon, when matter heats up, it expands. So I'm going to put some liquid nitrogen in this jug. I'm going to stopper it with a cork.
Wait,
And
wait,
then-
no.
No?
That's not a great idea.
What?
Okay, go ahead.
And then the expanding nitrogen gas is going to push the cork right out of the container.
Just stay right there. Don't move. Just stay right there.
It's gonna be
Everything's
cool.
fine. Everything's fine. It's perfectly safe. It's perfectly safe. It's. Did you pour it in there? Okay. Okay.
Shouldn't
Don't,
take
don't,
much.
don't tell me. I don't want to know. It's a little much for me. It's a little,
She poured it.
no! She's
fit.
poured too much. See that? That's what you get for pouring too much. No! Oh,
Where'd it go?
who's got the cork? Toss it up. I think I'm gonna toss it. I can't see a
Good
thing.
catch.
I can't.
Thank you.
I can't see. Oh, thank you. Who's got the cork? Thank you. Here. I can't play basketball, really. I'm not very good at it. I can't. Okay. That was pretty good. You know
That was
what,
very
though?
cool.
I want to show you the true expansion of liquid nitrogen. I have with me a flask. Into this flask, I'm going to place some liquid nitrogen, and we're going to watch this liquid nitrogen expand 700 times from a liquid into a gas, and I think we can catch all of that states of matter change. All right, here we go. We need quite a bit. This is a big flask. So I have a collection device here, the official Franklin Institute expandable lid. I think this should catch all the gas that comes off. All right, here we go.
How
and let's
big
give this a
lid
shot.
are
Here we
we
go.
talking?
It's pretty big, yeah. This is pretty big than your average container. In fact, this is what we call a 16-inch balloon. Most balloons are 10, so this balloon gets quite large.
Yeah, but for that volume of liquid nitrogen, you need a balloon that's bigger than your body.
No, we got it. We totally got this. As you can see, this balloon is going to expand. Okay, that's kind of big. Anyway, it might pop, everybody. If you don't like loud noises, earplugs. Is it big? How big is it, everybody? Is it big? Is it really crazy? Is it really? It's not supposed to get that big, actually. I don't know what's happening. This is it's a little bigger than normal. But this is the United States Science and Engineering Festival, so top shelf,
Anytime now.
Maybe it's not gonna blow today. This would be the one day in my life. It's really ridiculously big. Yeah, okay. It's even bigger up on the screen. Okay, time check. We're running out of time. Oh, we're fine. Oh, look. Woo! Yeah. Put that up in there. I got it.
I don't know.
It's good. It's good.
Yeah, but that just took way too long. Come on. No, okay. They liked the wait.
That's like saying it takes way too long to get to Disney World. It's still awesome. Still
Fine.
awesome.
Exothermic reactions. We're going with
Exo what?
exothermic reactions. Exothermic reactions are chemical reactions that release energy as either light or heat. And I'm going to show you all
Sorry.
some exothermic reactions that release energy in both forms as light and as heat. And because we have some different chemicals, I'm going to show you some different wavelengths of light. Now remember what I said earlier. The color of light is determined by the wavelength. So if different chemicals give us different wavelengths of light, we're going to get different colors. And the way we're going to see this is through something we like to call flame emission spectroscopy, which means, well, spectroscopy means look at the color, and flame emission, we're making fire. Let's see how this looks. This is lithium.
That's pretty cool. I like that. That's good.
Wait.
Let me get out of your way
We
and set my
have,
hair on fire.
where are you going? Fire.
I
Where
don't
are you
have
going?
much hair left, so you know.
Potassium. And my personal favorite, copper. if my copper spray bottle decides to work. There it is.
Hey, you
Heat
got.
and light.
Now, I think that was awesome, but I have a fairly new experiment to me. It's called the, well, I have two 5-pound balls here. And they are
Paul,
made
Paul.
of. They're,
Family
keep
audience,
moving, keep moving.
kids
They are
stage.
made of iron. But on this ball, notice I have a little aluminum and this one some iron oxide, also known as rust. What I'm going to do is I'm going to strike these two balls together. Now that energy is actually going to be changed. Some of it's going to be transformed into light, some of it's going to be transformed into heat, and some of it's going to be transformed, hopefully, into some really sharp sound. We're actually creating a chemical reaction that cannot be undone called thermite. Thermite reaction, right? It burns.
Thermite, thermite as in that reaction that people use to like burn through their car's engine block and then through the sidewalk below it.
And you've talked about reactions. This has its own oxygen. So once we actually start a true thermite reaction, we cannot put it out. It has to burn itself out. So here we go. This should be awesome. This is the most rust I've ever seen. Let's try aluminum striking. This is very difficult to do. Everybody, I need complete and utter silence. Stop giggling. No, I'm serious. No giggling.
Make some
no
noise.
giggling. Here we go. Stop giggling. Oops.
There he goes, dropping the ball again. Come on.
This is hard to do. It has to be a glancing blow. So, oh! Hold on. Goggle! Safety first. Safety actually at that time was kind of second, but anyway, you get the idea. Here we go. Woo! Thermite spheres, exothermic reaction. Thank you. Thermite spheres. Where? Thermite.
All right, who liked the thermite spheres?
Thermite spheres. Use your goggles, kids. Use your goggles. Make sure you use your goggles. It's important. And how many people like whatever the growly did? I can't remember now. I've forgotten. Okay. You know what? I might be losing, but I'm just so happy that there's so many young ladies here supporting science. It's awesome. I don't care I'm losing. I don't care. I care a little bit. I'm a man. All right, are we done? Do we have one more? Oh, you know what? There's only one thing left, right?
Yeah,
I think it was like a pick'em.
a pick'em? Do we want
is
to
that-
just do a you pick'em?
How much
Hey,
time do
do
we
we-
have? Okay, you know what? We don't have much time. Maybe we should go.
You know what? I think
Let's do that thing together we talked about.
yeah, we do have
Some-
the scores. Let's face it, I totally won this.
I think she won today. Let's hear it for the Growly. Yeah, Growly won this one. Growly won this
But you
one.
know,
Fine.
the only reason I'm winning is because, well, we decided to hold off on Paul's favorite demo. So what we're gonna do
We're
is
all
do that
winners.
one together
We're all winners.
at the end for this one. What we are going to do
Whew, okay.
is take some liquid nitrogen and put it into a sealed container. Now, for those of you who saw what happened with that balloon, I think you have an understanding that this is going to be a very powerful failure of that container. So as we do this, we're going to do this over here. We need everybody to make sure you keep your entire body behind the safety cones. We are going to put some liquid nitrogen into a 2-liter bottle. We are going to put that bottle in the big can, and then we're going to put a whole bunch of plastic ball pit balls on top. And then after an unknown length of time, our container will fail. We will have a massive release of energy as absorbed by those ball pit balls. It's going to be awesome.
Everybody,
Let's just do this.
not pass the cones. The cones are here for your safety and protection. This is going to be our spectacular ending the Science Showdown because really, whenever we talk about science, everybody wins. Science is awesome. All right, we have about 20 seconds. Here we go. Do not pass the cones right now. That bottle is expanding. That bottle, splash!
And that, ladies and gentlemen, is the Science Showdown. You're our winners. science